Howdy y'all, and welcome to Slope Applications, a lesson on slope and how it's used in the real world. We're going to call this lesson 12.8c, a little more focus on chapter 12, lesson 8. But lots of homework to review, so go ahead and I'm going to continue to go through pages, hit pause, come on back when you're ready. So there's 5 through 8, and here was 9 through 12. Again, hit pause, come on back when you're ready. Please notice that I've written the slope, y-intercept, as well as plotted and graphed the line. Pause, come on back when you're ready. And I have an extra slide here. Bring some questions when you got them, ladies and gents. Here we go. Focus today will be find a slope. Gee, that sounds kind of familiar, Mr. Cowan. Okay, so then here's the big deal. Write at least one sentence explaining, interpreting, telling what the slope means. So we have already spent lessons finding slope, finding its rise, finding its run. Now we're pretty much going to focus on doing the same thing only in real world and therefore describing what it is. For instance, this one compares dollars to songs. So how many dollars per song? If that sounds familiar, it's because we've kind of done some similar things. So I got a little PowerPoint presentation here. Won't be too terribly long. And here we go. So let's start off with just a basic reminder. What is slope? Slope is another word for constant rate of change. It is the description or relationship of the vertical change, the change in the y values, to the horizontal change, the change in the x's. In this picture, you'll notice on the graph, in words as well as in numbers, that all the vertical change is in blue, and all the horizontal change is in red. Now, if you're going to get into high school algebra, they'll often use this, where this Greek letter delta, it looks like a triangle, but usually one side is a little thicker than the other. The change, or delta y, change in the y value, minus the change in the x value. How do you find a change of anything? Why, you subtract. And oftentimes you'll see it written as a formula. Now, I'm not going to expect you to memorize all of this stuff, but there's all sorts of different ways in describing the relationship of the rise versus the run, the change in the y versus the change in the x, y minus y, x minus x. So let's get into an example. Table below, if you'd like to pause, read on your own, otherwise listen as I read. The table below shows the relationship between the number of hours Carlos works and the amount of money that he earns. Graph the data, then find the slope of the line, and lastly, explain what that slope represents. Now focus, please. Step number 1, graph. Step number 2, find the slope. Step number 3, kind of the big deal for today, explain what it means. So we're going to take all these relationships and we're going to create them as ordered pairs. We'll rewrite them as ordered pairs and plot the points on the graph. Now that is a strength of our class, so I'm not going to worry you about plotting points. Notice, please, I have connected these points with a line. Excuse me, Mr. Cowan, that is not a line. You cannot earn negative dollars. So we'll call that a ray. A ray has a starting point and goes on forever in one direction. Now let's find the slope and explain what it means. Now, many of us visual folks, you can see we have a rise and a run that always stays the same. That's why we call it a constant rate of change. We go up 15, another 15 is 30, another 15 is 45. So it appears to have a rise of 45. 45 what? I'm going to write dollars right there. And it appears to have a run of 3 hours. So I'm seeing a rise of $45 compared to a run of 3 hours, and you already know what we're going to do with that. Let's go ahead and convert that into a unit ratio. 45 divided by 3 is, of course, 15. And basically what we then get to do is we get to take the units and turn it into a sentence. Now I'm going to show you a different way of finding it. You could actually take the 2 points. Just a reminder, To find the rise, you would subtract the two y values. That'd be 90 minus 45. To find the run, you'd subtract the two x values. And to go a little further than expected, if I can just point out, Mr. Callan, what if we didn't do 90 minus 45? What if we did it the other way? What if we called the other point the first point and the second point? We switched them. Well, if that were the case, check this out. So 45 take away 90, 3 take away 6, 45 take away 90 ends up negative 45, 3 take away 6 ends up negative 3, and look what we have. The opposite of a negative is a positive. You'll get the same quantity which can be reduced, and ladies and gents, we can turn that into a sentence. For every hour that Carlos works, he earns $45. Or excuse me, he earns $15. You could also, I was kind of getting ahead of myself, you could also say his wages increase. I like looking for words increase or decrease. His wages increase $15 per hour, however you'd like to say it. If you recall on my previous slide, oh, it'll be nice. Notice here, there's a reason why I wrote the ratio with the units so that it makes it a little easier to write dollars per hour. All right. Let's go ahead and give you some time. So pause. I'm not going to make you graph it. So let's just pretend the graph's already done. I think that's a class strength of ours. I want you to find the slope, explain what it means. Pause. Come on back when you're ready. First things first, we can find some good, nice points. When I say nice points, I mean nice integers that you can tell what they are. For instance, this guy right here is 20 pages, but what would the x value be? Hard to tell, isn't it? Is it 1 4/10? Is it 1 5/10? Is it 1 45/100? So let's not use that point. Let's use 2 points where we can easily find the rise and the run, the rise and the run. In this case, all of these seem to increase 30 pages for every 2 hours, and naturally 30 pages for every increase of 2 hours could be simplified. And therefore, the correct choice here would have been C. The slope of 15 represents pages read per hour. I would have said the amount of reading increases 15 pages per hour, something like that. Lots of different sentences. Be as clear as possible, ladies and gents. Only a couple more examples. Again, here we have an interpretation. So either pause and read on your own or listen as I read it with you. In terms of aquariums, Nina drains a 20-gallon aquarium at a rate of ½ gallon per minute. Draw a graph to represent the amount of water in the aquarium versus time. Find the numerical value of the slope and interpret. So once again, we got 3 action words here. We got draw, we got find the slope, we got interpret the slope. So if we were to draw this, I would guess this would be a strength of hours starting at 20. It goes down 1/2 every 1 and another half every 1. Excuse me. It goes down to 19.5, then to 19, 18.5, 18. Please notice the scale down below appears to go at 2s. All right, so find the slope. Well, listen, Mr. Callan. You can go down 1 and write 2. You can go down 2 and write 4. Down 1, write 2. Down 2 and write 4. Frankly, they already told us in the problem. This is a decrease of 5/10 or a half. Okay, half of what though? It's a decrease, or it drains at a rate of 5/10 of a gallon per minute. Yeah, you could say 1 gallon every 2 minutes, but I'm gonna be frank here. That's not the best way because it's not a unit rate, but it is technically acceptable. 1/2 a gallon per minute is the same as 1 gallon every 2 minutes. All right. So please notice that if you don't say the word decrease, you need to use numbers and symbols to express that it's going down. So you can write a negative 5/10 of a gallon per 1 minute. They write negative rate of change. Using words like drain or decrease will explain that in a much more concise manner. Last one for you, folks. I'll give you the graph. Go ahead and pause. So draw, oops, sorry. Let me get back here. Draw is already done. Find the numerical value of the slope and interpret what it means. Pause, come on back when you're ready. A number of points available here. All of them will have a constant rate of change because they all seem to be decreasing 20 what? 20 what? Okay, $20. We're talking balance here. And it appears to increase 1 week. So negative 20 to 1 can be divided or written as a unit rate. And of course, since we've written it in there, we can write it in words and create a sentence to describe that. The slope is negative 20. What does that mean? Now notice here they use the word fall. You could say goes down. You could say decreases $20 per week. Frankly, I'm not a huge fan of their sentence. I think we can do better. That's what I got for you, ladies and gents. So onward to assignment number 11. Go ahead and write that at the top of your paper. For those of you that are virtual only, put your work in Cami. Everybody else should have paper. Take care, folks. Do well. Let's grow. See ya.